Have you ever found yourself maybe nodding along when someone's talking about AI or machine learning or deep learning?
Oh, definitely.
And you're sort of secretly wishing you really got the differences, not just, the buzzwords.
That happens all the time. They get thrown around almost interchangeably.
Exactly. It feels like these really powerful terms just end up creating more confusion sometimes. So today we're doing a deep dive into exactly that.
Good.
We actually got these fantastic handwritten notes, really well laid out, outlining these concepts. Our mission today: unpack these notes, pull out the core nuggets so you can quickly get genuinely up to speed. Okay, let's unpack this.
Yeah, and what's fascinating here is how often they get mixed up. But nailing down the distinct differences and crucially how they relate to each other, that's fundamental if you want to navigate, the tech world today.
Absolutely.
And these are notes. They really give us a remarkably clear path through it all.
That's a perfect place to start then. So let's begin with the biggest one, the main umbrella, artificial intelligence, AI.
Right.
Our source material calls it simply intelligence systems. But what does intelligent really mean here?
Yeah, that's the million-dollar question, isn't it?
Yeah.
When we say intelligent for AI, we're talking about systems that can do tasks normally requiring human intellect.
Okay.
So things like perception, reasoning, learning, problem solving, even decision making.
Can you give a simple example? Like the notes mention a dog or a tiger.
Sure. Imagine an AI system looking at a picture. Perception is seeing the image data. Reasoning might involve figuring out features, fur, stripes, paws. Learning comes from seeing lots of images. Problem solving could be distinguishing a dog from a tiger, which is pretty important.
Right.
And decision making is the final output. That's a dog or that's a tiger. It's about acting towards a goal based on that input and processing.
Okay, so AI is the big picture, the overall goal of creating systems with these human-like smarts.
Precisely. The grand vision.
So if AI is the vision, then machine learning, ML, seems to be the engine driving a lot of it. A type of AI for building methods for machines to learn.
Exactly right. ML is all about using data to get better at a task over time, automatically. And the absolute key difference from old school programming is no explicit programming of rules.
That sounds huge.
Oh, it is. It's a massive shift. Instead of a programmer writing code for every single possibility, the machine learns the patterns from the data itself. It gets to decide based on what it's learned.
So no more writing endless if-then statements for, say, recognizing every single dog breed.
Exactly. You show it millions of dog pictures, and it figures out what defines dog.
The notes give good examples like that, recognizing a dog or classifying an animal, regression predicting a value, and classification sorting things into groups, like separating different colored dots.
That's it. Regression finds the trend. Classification draws the boundaries. Both learned from data.
Okay, so AI isn't the same as ML. ML is a subset of AI, a way to achieve AI.
You got it. But that brings up a question, doesn't it? If we're not programming the rules, how does it actually get smarter? Especially with really complex stuff.
And that leads us perfectly into the next layer, deep learning, or DL. The notes say it's a specific ML type.
Right. And the defining thing about deep learning, it's structure. It uses neurons plus synapses, basically mimicking the interconnected layers of the human brain.
Like a neural network.
Exactly, but specifically deep neural networks. It's these multiple layers, the notes call them hidden layers, stacked on top of each other. That depth allows DL to learn incredibly complex, subtle patterns in data.
Patterns that regular ML might miss.
Precisely. Things that aren't obvious, patterns that are hierarchical or highly nonlinear. It's almost like the system develops its own kind of intuition from the data.
And the key is lots of hidden layers.
Yes, depth is key. But that depth comes at a cost. Deep learning needs two crucial things highlighted in the notes. Lots of data.
Makes sense. More layers, more connections to train.
And a lot of CPU. Specifically mentioning GPUs, graphics processing units.
Why GPUs?
Because training these deep networks involves tons of parallel calculations, which GPUs are brilliant at. You're tuning millions, sometimes billions of parameters. It takes serious computational muscle.
So tons of data, lots of processing power, and as it sees more data, the network changes.
That's right. Connections between neurons get stronger or weaker. Some might even be removed. It's constantly adapting and refining its internal representation of the patterns it's learning.
And this is where we see those really impressive applications pop up, right? The notes list things like computer vision.
Yeah, teaching computers to see.
Natural language translation, self-driving cars, image recognition. It also mentions CNNs.
Convolutional neural networks. That's a specific type of deep learning architecture that's particularly amazing for image processing. It's a big part of why computer vision has gotten so good.
Okay. And even text-to-image generation. This is where it starts to feel really futuristic.
It really is. And that ability to generate things brings us nicely to the next category.
Which is generative AI, or Gen AI. The notes position this as a subset of deep learning.
Correct. So we're getting even more specialized now.
Moving beyond just understanding or classifying to actually creating stuff.
That's the essence of it. Gen AI is backed by these complex neural networks, often very deep ones, and critically, it frequently uses what are called foundation models, or FMs.
Foundation models, what are those exactly?
Think of them as massive models pre-trained on enormous amounts of general data, often text and images from the internet, usually unlabeled data. They learn fundamental patterns of language, imagery, logic, etc.
So they have a broad base of knowledge.
Exactly. And the beauty is, this pre-trained foundation model can then be adapted or fine-tuned for lots of different specific tasks without starting from scratch each time. It's much more efficient.
And the kinds of things they can create. The list here is pretty mind-blowing. Generating text, summarization, extraction, image creation, chatbots, Q&A systems.
Yeah, it's incredibly versatile. It's not just analyzing existing data. It's synthesizing something entirely new based on its learned knowledge.
So it's moving from analysis to synthesis almost.
That's a great way to put it. Gen AI can create something new from what we know. It's about the machine becoming, in a sense, creative, a collaborator.
And when we talk Gen AI, especially for text, the term transformer models comes up a lot. The notes link these to large language models, LLMs, and say their main job is to process sentences.
Yes, transformers are a specific, very powerful type of neural network architecture that revolutionized natural language processing.
What makes them so good?
Efficiency and context. The notes say they're fast, meaning more efficient, and requiring less processing time compared to older methods. Crucially, they have a mechanism called attention, which allows them to weigh the importance of words relative to each other in a sentence and understand context.
So they don't just look at words in isolation.
Exactly. They understand how words relate across long stretches of text. That's why models like BERT and GPT, mentioned as examples in the notes, can generate such coherent and contextually relevant language. It was a huge breakthrough.
Okay, that context part feels really important. Now, one more cutting-edge area mentioned, multimodal models.
Right. This is really pushing the boundaries.
The notes say they're not reliant on single input and have no single output type. What does that mean in practice?
It means they break free from the limitation of dealing with just one type of data at a time. A multimodal model can handle a mix of inputs simultaneously, maybe audio, an image, and some text describing it.
Wow, so it can see, hear, and read all at once.
Essentially, yes. And likewise, it can produce a mix of outputs. The notes distinguish two main types, MM embedding models, which are good at understanding and finding relationships between different types of data,
Okay.
and MM generative models, which can actually create new content that spans multiple modalities. Imagine describing a scene in text and having the AI generate both an image and suitable background music for it.
That's incredibly powerful, handling data more like humans do, using multiple senses.
Exactly. It's about integrating different forms of information for a richer understanding or creation.
Okay, phew. We've gone through AI, ML, DL, Gen AI, transformers, multimodal. Let's try and zoom back out and really connect all these dots. The listener's nested diagram is super helpful here.
It really is. It shows that layer relationship perfectly. AI is the big outer circle.
Right.
Then ML is inside that, DL inside ML, and Gen AI is a specialized part of DL.
And the notes give these really concise summaries for each level's capability, which I think are worth repeating.
Yeah, they're great for AI generally. If this happens, do this. Capturing that goal-oriented decision-making aspect.
Okay. Then ML. We classify based on past pattern, learning from examples.
Yep. Then DL takes it further. Decision based upon past learning, implying that deeper, more complex pattern recognition through those neural networks.
And finally, Gen AI. Sometimes we are creative, create something new from what we know. That's the inventive step.
It really boils down the progression nicely, doesn't it? From rule-based decisions to learning patterns to deep pattern recognition to actual creation.
It does. So what does this all actually mean for you, our listener? Why does untangling these terms matter?
Well, I think understanding these distinctions really empowers you. You can cut through the hype and headlines. You can better understand what a new piece of tech actually does.
Right, you can ask smarter questions. Is this new product just clever ML for classification? Is it using deep learning for complex perception? Or is it truly generative, creating something novel?
Exactly. Knowing the difference helps you gauge the actual capabilities and, frankly, the potential impact.
So we've covered a lot today. We journeyed from broad AI down through machine learning and deep learning into the creative power of generative AI, and even touched on those multimodal frontiers. Hopefully, digging into these excellent listener notes has made the landscape much clearer.
Yeah, and if you connect this to the bigger picture, this progression we've talked about, from systems that learn patterns to systems that can generate completely new content, it's fundamentally changing how we interact with technology, with information itself.
It feels like a profound shift.
It is. We're moving from tools that just assist us to tools that can collaborate, invent, and engage in ways we're only beginning to explore.
Absolutely. Which leaves us with a final thought for you to ponder. As these different levels of AI evolve from basic classification right up to complex creativity, how might they reshape not just the tools we use every day, but maybe even our own definition of what intelligence means? What specific real-world problems are you already seeing these different AI types solve? Or perhaps more excitingly, what challenges do you think they could tackle next? Something to think about.